That was Grace's question, basically right there, and the answer is no. And what that means is you'll be given the compound. Okay. So what we need to do is on page 87 then. Okay. It's a great place to sit, isn't it? Yeah, sit at that table. The periodic table.
Oh, wow.
Huh? I need a place to sit. Okay.
It took me a moment, and then I got it.
Okay. All right. So let's see here. One of the things that may throw people off between either from freshman year to here, or maybe from this point to when we get to chapter 7, when you look at number 5B, it's saying how many, determine the mass in grams of the following. So you're starting with atoms, and it says chlorine. So if you remember anything about this in physical science, anytime you dealt with chlorine, that's a halogen, you have to remember that it is what? That it is diatomic. But in this case, where they're just asking for chlorine in general, you just deal with one chlorine, not two. Unless it says otherwise. Because on one of your papers I handed back, it did ask what is the number of grams found in, I don't know, 3 moles of O2. It didn't say oxygen. It went ahead and said O2. But in this case, we're not dealing with diatomic molecules yet. But otherwise, we would. It'll say it on the paper if we want it to be diatomic. Okay. So we want to find the mass in grams of 3.01 atoms. Atoms of chlorine. Because otherwise, again, when you would have seen this in physical science, you would put a 2 there because it's diatomic. But we're not dealing with that yet. Okay. So how do we get this to cancel out in our next step? Okay. So with that, that constant is what? Again, that is atoms, chlorine, and then that gives you what? 1 mole of chlorine. Okay. So notice our atoms are gone. We're in moles. Our final step would be what? Okay. So for every mole of chlorine, which you're not dividing, you are
oh, you want to do grams? Never mind. Oh yeah, safety is not
moles are gone. Okay. And then when we do that, okay, take your handy dandy calculator. Chances are it's going to be 3 times 35, so it's probably going to be somewhere around 110, I'm guessing. Because the powers probably cancel each other out. 3.01 second exponent to the 23rd times 35.45. Enter, and divide that by Avogadro's number, 6.022. And that gives you, I was way off, 17.72 grams. Is that what you got? Okay. 17.72 grams chlorine. Okay. And one of the aspects we're going to have, once we get past Okay? Probably 2 weeks from now, when we get into the 11th of September and further on, we'll be getting away from the calculators and be dealing with the electron. Okay? And that goes back to Tom's favorite part, slide rule. Well, that would be tough going down it then if it's rough. That would hurt. Huh? Zingers come quick in the Thunderdome, don't they? Oh, okay. Sometimes you gotta duck. Maybe. Sometimes I just want to. What's that? I don't have to duck. You usually go over my head. Oh. Then you can duck. Okay. So we can, yes.
So on this house, does it matter to what place we round to?
Nearest one.
That's for both scientific notation and.
Correct. Do we want to continue, or do you think we're good? Okay. This is why.
Can we change like grams to atoms?
Grams to atoms. Okay. So I'm just getting these on page 90. Oh, you said grams to atoms. Okay. With that, we'll just shoot from the hip here. They don't have us make up a problem. So let's go ahead and say how many atoms of rust.
What is rust?
Rust. Iron oxide.
Is it O2 or anything?
Yes.
Iron 2. Forgot what that means.
The charges.
Okay. So how many atoms of rust or iron 3 oxide are found in how many grams, Tom?
74.
Okay. Point.
06.
Okay. So you have 74.06 grams of iron oxide or Fe2O3. Remember, you can abbreviate that just as long as you know that this means that. Okay, there's only one place to start, and that is with 74.06 grams of iron oxide. Okay, so how do we get rid of that gram? Okay, so grams is upstairs. Where's it go on our second step? Okay, want that to cancel. So you add up all your atomic masses to go here, and that would give you one what? 1 mole of that substance. Okay, so once we add all them together, Okay, 159.90, okay, grams of iron oxide. Okay,
Yeah, 27.
oh, from them 2 5s, okay. Yeah, gotcha. Oh, I looked at them 8s thinking that they were 9s, that's why. Okay, 70, that's a 7. All right. So now our grams are gone. We're in moles. Now we gotta get rid of your mole. Okay. So for every mole of iron oxide, we get how many atoms? Remember, anytime you see the word molecules or atoms, it doesn't matter one way or another, you will be using that constant. So these are gone now. We got our atoms right where we want them, the upper right hand corner, because that's what it's asking for. So then when you multiply that out, remember when they're next to one another, you multiply. If there's anything on the bottom, then you divide. So 74.06 times 6.022, then hit your exponent or second double E to the 23rd, and then divide that by 159.70. 2.79? Yes. And again, that is atoms of IO. Now, more often than not, I would like to think that probably 8 times out of 10, as long as you keep doing this, you're going to be just fine. Then there's maybe 1 person out of 10 who doesn't have to do any of this but can still keep it straight, and then that other 1 out of 10, maybe they get lucky. Okay? It's one of those aspects we want to make sure. Please keep showing your work, and then that makes it easier to see that these are canceling out with one another. Good. Left outside, you on the bus?
Yes.
Left middle, right middle, right outside. We got a high gloss up here. I was afraid that these lights might be reflecting off the chrome dome and might be blinding the video. Because it's something's glaring. Oh, that's just the lights. It's not my forehead.
So is there a problem for just doing over questions like this?
That is correct.
So just like the questions that we had on our 2 previous worksheets?
That is correct.
Okay. Nothing else?